Hi there. In today's video I'm going to talk about how to solder a full port 3/4 inch ball valve. In this case this valve is a Nibco HydroPure lead-free ball valve. This is actually lead-free bronze. It's a quality ball valve, and today we're just going to go over how to solder it and get it prepped for your plumbing situation. So first of all, I'm just going to recommend that I'm not a plumber. I'm just offering an opinion. I hope you find the information useful. So again, let's get right into it. The first thing I recommend to anyone doing any soldering of the ball valve that they may never been familiar with, in this case this is the first time that I'm soldering a Nibco ball valve, I want to validate with the manufacturer as to which way they recommend to have the ball valve soldered. And what I mean by that is, right now the valve is in the fully open position. Now it's fully closed, and as you can see the ball is fully closed, okay? And this is a half, okay? That's about halfway open right now. What we want to validate is if the company recommends a certain way that this shall be soldered. And this company, at the time of this video, when I called them, they recommended having it in the open position. Some companies may offer different advice, but in my case they said open, so I'm going to go open. So once the valve now has been set in the open position, I'm now going to take my adjustable wrench here, okay? And what I'm going to do is I'm going to remove the nut here and the handle. So this way we can get these things out of the way, all right? So let's remove the nut like this. And now the handle. Okay, so now we're just left with the stem, and we're left with the packing nut and the valve ready to be soldered. In this case, I'm going to pick this side here to be our point for the demonstration. Okay, so this is a 3/4 full port, so I'm going to get a 3/4 fitting brush, and what I'm going to do is I'm going to stick it in the socket here, and I'm just going to clean it. So depending on how old the valve is, if it's new, if it's been sitting around, you want to clean the inside of this thing very well. So as you can see, I'm just turning it, you know, I can turn it both ways, doesn't really matter. But what you want to make sure, you see some shiny metal, okay? In this case it's yellowy metal, so we're going to look for a yellowy brass color. And one important thing, even after you clean it, inside there it may look extremely clean and so forth. But what I found over doing many solderings of these ball valves is that there is grit and stuff in there that you don't want. And as an example of that, here is a brand new clean Q-tip. Okay? So if I go inside now and I see that the metal's all shiny, but then I look inside and I see that there's stuff, alright? We now see that there's stuff on that Q-tip that wasn't there before. So I want to give the best possible chance for proper soldering. So when I've got my ball valve, you know, soldered, the crunch that's in there from just using this fitting brush, okay, it doesn't leave me problems. So I'm not saying to use a Q-tip, I'm only using it as an example, okay, but as you can see there is some black, okay. Here's a clean end. Okay, this is a brand new clean Q-tip. And I start going in here and I'm just cleaning around here. And there's a bunch of garbage in there, so I don't want that in there. So I'm using a Q-tip as an example, but for you, you know, you can use a nice rag, okay? Just something to get in there, make sure it's nice and clean. Don't use water, only because, well, we want a dry surface for the flux to be applied. So we've cleaned it up. Now we have a nice clean surface with no debris, nothing. Okay. All right. So now this is our socket or ball valve. Okay, that's been prepped. So now we're going to set it out, you know, out of the way. For our example, we have a tube. We have a brand new piece of copper here, and what we're going to do is we're going to cut it. So just to show you how to do all that, I'm going to take my my pipe cutter here, okay, and I'm just going to cut a new end here because I got a bad end. So I'm just going to cut a new end, okay, and notice here how the tubing wheels and the cutters they're nicely aligned. I put a bit of pressure and I start to turn. And what you're going to notice is that there's a line beginning to form on the pipe. See right there? That line is beginning to form right now as I'm scoring this pipe. And that's what's going to happen is you're going to see the pipe just come loose. See, we're almost through. And there we go. We have a nice square cut. Okay? But if you look really inside right here, we got a burr. So you're going to see, so look at this now. Now look what's going to happen after I deburr it. Now on the rigid cutter here, the number 15, if I go here and I were to ream this pipe, it's going to do a pretty good job. See, there's lots of stuff coming out, and as you can see, we're removing that burr. But unfortunately, in my experience, these work very well in terms of these. They're just not my preferred method, okay? So what I'm going to do, I'm going to go to another deburring tool, and you're going to see now exactly why I prefer this. So I'm going to take this, generic reaming tool, deburring tool, and I'm going to go on the inside of the pipe. And what's happening is you're starting to see a bit of you're going to get little shavings of copper that are going to start to form. Maybe hard to see in the video, but right here at the edge of the Q-tip, you're beginning to see some copper form right there. See that little piece of copper right there? That means we're cutting copper away and we're making a nice smooth transition. So as you run this around a few times, you're going to get an extremely smooth inside piece. And the part of the copper that we removed was that little burr. Okay, that little burr is going to be not in our pipe causing turbulence or water issues down the line. See, because if you don't deburr the pipe, what could happen is you're going to get turbulence or a lot more noise in the water flow as the water is rushing past this newly cut piece. So I'm going to keep doing it until I see no more burrs. And again, to make sure that you know, to see exactly what you're doing, look for these shavings. Okay, you're going to see that these have actually come out of the pipe. Now to know if it's good, just be careful because it still may be sharp. I take my hand now. I'm just going to feel inside this pipe. I want to make sure there's absolutely no burr. Now as I rub my hand, I'm still feeling something. So once again, I'm going to go around here. Just going to make sure there's absolutely nothing. So depending on what happens here, we're going to get shavings like this, and we just don't want those around. So you take your finger and you're going to feel. So now we've taken care of the inside of that pipe, okay? Now the outside is not so clean. It's still very dirty. So what we're going to do now, we're going to take our waterproof aluminum oxide paper here. This is a 120 grit. Okay, right there it says 120. Now what we're going to do is we're going to take this and wrap it around the pipe. So let me put my glove back on because it gets kind of dirty. And we're going to get rid of all this oxidation. Now in reality, you're going to go much quicker than this. I'm just kind of slowing down so we can get a feel for what's going on. Alright, so see, if you compare these two, you got very shiny, clean, and just dull. Okay. So the rule of thumb is for the copper pipe, if you can clean at least 1 inch of 3/4 pipe, right, you know that you're going to have nice clean solder, a good clean solderable surface that when you're going to engage these two in, you're going to have plenty of clean pipe. All right. So we're just going to go like this. We're just going to keep cleaning. Rub it around. Now once again, you're going to see there's a bunch of grit there. All right. So I'm going to, again, just to show you here, I'm going to take some brand new Q-tip. And I'm just going to run this across the thing. And what you see, again, it just turned black. Probably hard to see, but it's really black. It's garbage. There's a lot of stuff there. Even on the inside, right? This stuff goes everywhere. So again, see how dark that is? So that right now just came from me sanding this pipe. So because I'm wearing gloves, right? Even then all this copper stuff is getting on the gloves, as you can see. It's all just coming off. Take the tube or the pipe there and just kind of wipe it, all right? So now we've got a clean surface on the exterior. We got a clean deburred pipe on the inside. And if you want, there's a bit of crud inside there now too. Take the pipe here and clean it out, baby finger or some kind of Q-tip, whatever. Just get as much of that stuff out of there, because when you're going to solder and put the water on, any crud that's left in there is going to travel through the plumbing system. So the less you can get rid of it now, the more you can get rid of now, the better, okay? So we've cleaned it, and here's our prepared socket. What we want to do is you want to test fit. So put it in and try to fit it in the pipe. Now I try to rotate it when I'm putting it in there to make sure it's going to fit well. If I can put it in all the way and it's rotatable, that means we're pretty good. It wasn't really hard to, it's not fighting me to really get it in there and really hurt. Like, it's simple. It's not much effort, you know what I mean? Simple. It just pushes in and that's it. So after I've got my test fit, I'm going to get a marker here. I'm going to mark how deep this is. All right. So my initial test fit is ready to be learned. So there's my black mark. Okay. Take the marker. And as you can see, you're looking at maybe anywhere from 3/4 to 7/8, about an inch of depth. And basically what we're going to do is we're going to solder this all the way from end to end. Okay? So after you apply the flux, this is all going to be filled with solder. Okay? So we're going to prep the joint, and then we're going to get it ready for soldering. Alright, so now what we do, we're going to now apply flux inside the socket here, and we're going to apply flux to our prepared pipe. So I'm going to just take my Lennox brand water soluble flux here. Okay, I just want to show you what that says. It says water soluble, NSF certified. Again, this is one brand. Again, many are compatible. All right. So I'm gonna go here. So I take my my flux brush and I'm gonna just stir up a little bit here. All right. Get some good things. And what I'm gonna do, I'm gonna apply enough to coat the inside of the socket, but I'm not gonna go overboard. All right. So what we're trying to do, we're trying to go all the way. Remember, inside the socket here, there's this little piece of ridge that stops the pipe from going all the way, or the tubing from going in. All we're trying to do is go all the way to the bottom. Everywhere that there's flux, solder will stick. All right? So we're just going to put here some flux. See, we're just coating the inside. All right, we're just coating the inside all even. All right. Remember, any excess flux that's in this socket, when you put this inside, all that extra flux is going to go into here. So again, just put a little bit, but not a lot. All right. So we're just going to now go like this. See, again, make sure we're totally coated. Okay, so there we have our nicely coated piece. Put that there. Now I'm going to take our pipe here, tubing, and I'm just going to now coat this as well. And because we have that line, we know how far to put the actual flux. So what I'm doing is a preferential thing. I'm just going to stick it all one direction here, and I'm going to rotate the pipe. And then I'm going to go the other direction, perpendicular, just to make sure that I have absolute coverage. Alright? Because the flux is, it helps in soldering, it also helps bring the pieces easier together. So we're good. Now, here's a tip. If you have to leave this for more than 30 minutes, wipe up that flux, okay? Do not leave that flux sitting there for more than 30 minutes straight. I recommend that only because this will begin to turn the pipe green, and it kind of almost like, it makes it harder to solder, okay? So right now it's like a whitish translucent color. If it stays more than 30 minutes, you're going to begin to see it start turning green. So just, if you're going to do the soldering, make sure the soldering is going to happen within 30 minutes. Also, on your flux brush or acid brush, make sure it's clean in terms of it's delivering solder, it's not delivering gunge, right? This looks bad, but it's actually okay, as long as you're not putting more grit on here. All we're wanting is flux and a clean pipe, okay? So with this done, we'll just put the flux over there. We're going to take the two, okay? We have our fluxed socket, fluxed pipe. We are now going to stick them together. Alright, we're going to put them together, and I'm going to turn. I'm going to rotate. That evenly distributes the solder paste all the way around. But you see here we've got some solder paste around the side here. I'm going to take my rag and I'm just going to wipe that up. Okay, I'm going to wipe that up. So now the solder is going to be a much cleaner joint. Okay, so we wiped it up. As you can see there, see we have a nice solder preparation. There's no excess flux anywhere. Okay, and we're prepared because really that space between the pipe and the tubing is very small. Okay, so we're going to fill that with solder now. So for our demonstration, I'm going to stick it here in the vise. Now again, if you're going to do it in the vise, just be very gentle. Do not over tighten. All right. So our tubing is prepped here. It's fluxed. There's our line, so we know we're deep enough in the socket. Okay. Now, before I start going ahead and putting power with the torch and fire, here's my torch head. Now, this torch head in the video is going to look pretty big, but in actuality, okay. And again, torch head sizes vary. But if I show you the diameter of this with respect to the tube, this tube is about 7/8 of an inch diameter. This torch head, if you see here between the 3.5 and 4 mark on the tape, you're looking at maybe 1/2 an inch across, maybe 5/8 of an inch. I don't know if you can kind of really see that in the video. But the dimension of this diameter of torch head is around, 1/2 inch, maybe a little bit more. All right. So that's just a scale to show that now when it comes time to put the torch in the video, we're going to try to demonstrate what we're going to do. Lead-free alloys like the bronze and even some lead-free brasses, they don't conduct heat like the old leaded brasses or leaded bronzes did. But even still, general soldering technique will tell you that in order to heat up the space between the tubing here and the socket, I want to heat up both the socket, which is where the tip is touching, and the tube. This way heat goes from the tube into the socket, and also from the socket it heats up the tube. As long as the space between these two has good even heat, the solder. For our example, I'll be using this solder today. Alright, that's exactly the solder I'm going to be using. Alright, that's the stuff. I want to heat up both this and this nice and even. So I'm going to go around, okay? I'm going to really come around here to make sure that we're nicely evenly heated. And what's going to happen is when it's just the right temperature, solder is going to be coming around like this. Now, we're going to heat this up and we're going to heat this up. Now really the only way for me to know is just by touching it, okay? I don't know by time, I just know by experience. So as you're watching, if you time this and look at how long it takes for the heat to go, we'll maybe give you some kind of indication. I am using MAP gas, okay? I am using MAP gas, but what I'm going to do is I'm going to adjust the flame so I don't have a really large flame. I only want maybe a 1 inch to 1 1/4 inch long flame. I don't need the whole 2 inch heat, all right? So the nice torch, it gets very hot very fast, so I don't need a lot. Now, in order to figure out how much solder I actually need, here's my actual piece, all right? But the general rule says for 3/4 pipe or 1/2 inch pipe or 1 inch pipe, whatever, you only need about, in this case, 3/4 pipe, 3/4 solder, 1/2 inch pipe, 1/2 inch solder, 1 inch solder, and so forth. So I'm just going to roughly, you know, get a measuring tape here, and I'm just going to say, hey, here's my 3/4. So I'm going to measure, and roughly right here is my little, that's my little bend of copper. Sorry, of solder. All right, and this basically is the amount. So we should stop right about here where my finger is. That we shouldn't have to go any further for adding any more solder. Now, I like to keep the solder long. In my case here in your video, this solder length is about 9 inches. All right, so this way I'm far enough away to not get burned because this is going to be really hot. Okay, so watch as I apply the heat to the tubing and the socket, and we'll see how good of a job we can do. So I'm going to turn the MAP gas on full high, and then I'm going to turn down the actual flame. And again, I've got the safety goggles, the water, everything around me here is not going to burn, so it is protected. I've actually wetted this piece of wood, so we're not going to burn. The bench I'm on has been wetted. The floor I'm on is cement, so we're pretty good. All right, but again, just be safe. Just make sure that everything you're doing is not going to have a fire. So here we go. I'm going to start the torch here in frame. Okay, so I've applied the heat. Just going to take my rag. Just going to attempt to fur out the joint here. It's still a bit hot, so we can shape it with a dry rag. And as you can see, there's some solder coming off. Now this is very hot. Don't be tempted to get some kind of rag that's wet and so forth. Just let it do its thing. All right. Now, the initial shaping of that joint may look okay, but what I'm going to do, I'm just going to reheat it up, and you can still do this. But be very careful not to burn or melt anything now because this is still warm. Remember, there is some seats down here for the Teflon seats within the joint here. So do not overheat it too much. Now, if you look at this, you'll see that we ended up exactly where the 3/4 was, and the capillary space between the socket and the tube is nicely finished. So let's go back again. Just going to turn the torch on. Let me see if I can get in frame here. Okay. Snap gas, but it's not too hot. I'm going to go back here and I'm going to touch this up. It turns liquid, and you can just touch it up. And that's really it. So now we're going to let this sit, and then we'll take a look to see how we did. Alright, so now we've done soldering. I want to show you what we have produced here, and as you can see, we've got a pretty good filled socket to tube connection. See, it's nice and smooth. We have a little bit of a ridge. That's okay. See, there's not a lot of solder. There's no mess. There's no nothing. And that's what you want. Something that's nice and something that looks nice and no spatter, no other issues. All right. Now, we've got a clean joint because after this had cooled down, we took a rag that was wet. You clean up any excess flux. So if there's any excess flux on the socket, on the tubing, you want to get rid of all that so it doesn't turn green and could actually corrode the pipe and cause a leak in the future. So you clean it up so it's nice and dry. All right. But again, make sure you let it cool down. Do not shock this joint by putting in lots of water. You know, don't dunk it in a bucket, and don't dunk it or douse it in cold water, and then whatever. Let it cool down 10 minutes, whatever, and then move on. Okay. So now, here's the ultimate question. Up here, this looks pretty good, right? This looks like a really good joint. It looks like we're okay. But since I've never soldered with this brand of valve before, and it's a lead-free bronze, right? This takes a lot more heat and a lot more workability because the heat transfer from the copper tubing to the bronze alloy is, well, there's a big difference there. This one takes a lot more heat than the copper tubing, so that's why when you solder, I recommend soldering and you heat up both the tube and the socket, okay? Because the bottom line is you need solder to go all the way. You need solder to go all the way down here, not just here. It's got to go down here. So as good as it looks right here, you know, we care about the waterproofing all the way down here. So this whole 7/8, 3/4, 1 inch space got to be full of solder. And a good solder joint will have at least 70% coverage. So now in my case, the only way to know if this is actually good is I'm going to pull this apart. All right. So what I'm going to do is I'm just going to I'm going to rip this valve apart, and I'm going to cut it, and I'm going to show you what you should see in terms of a successful solder joint. Alright, so basically here's the result of our solder joint. Basically it was like this. Now it is now separated. So in order for you to really know exactly what should be a correct joint, all right, you really got to practice, and really the honest way is to buy a valve and basically make sure that you get results like this. Remember when we put this piece of copper into the socket here? Remember, this is our socket and this is the initial part of our valve. We deburred the very end of this piece of copper. Now, another reason that that would be important is as soon as you have a space that the solder can actually get all the way to the bottom of the joint. Remember, this here is the bottom, up here is the top. And as you can see, you barely don't even see a line of where the copper meets the lead-free bronze. All right, you barely see anything. But it's that capillary space that is waterproof for a very long time. But the point of what I'm doing here, if you see solder all the way at the bottom here, that's where the waterproofing begins. When the water is coming through or coming whatever direction in this situation, the water is going to try to go from here and then try to bypass up the sides. All right? When water cannot get anywhere because it's waterproof, now the water just beautifully flows by. And as you can see, even if this here, if the water is flowing this direction, maybe you can see a little bit better there, it looks like there's a ridge, like there's a bump. But actually what that is, it's actually concave right here. So the water is just going to skip past that and have no problems. All right, that's the beauty of a good solder joint. But even still, as good as this is here, the only real way to know is we have to rip this apart. So what we're going to do now is we're going to put this back in the vise. And we're just going to rip this apart to see what happens. So as I flatten this, we just want to know what's going to happen. And if we get a good result, then we know for the future. So now, we can get a hammer, or we could get a lot of things. Probably a simple pair of pliers. And all we want to do is we really just want to bust break this. All right. Okay. So here is the joint. Okay. So as you can see, we have a very few sections here that are not covered. So this joint here is, I would say, very good. Perfect? No. Very good? Will it last a very long time? Yes. And here's the real proof. All right. Here is your copper. All right. Here's the copper. Look at this. If you don't see any copper in this section, other than where the tip of my baby finger is, right, then you begin to notice that we got a pretty good joint. All right. Look. See that? Pretty good joint all the way around. And the reason why that is because we don't overheat the joint, so we don't burn the flux out, but we also have good coverage. See here? Look at the solder. It went all the way down. All of it. It went all the way down. All right, which is perfect. That's a good thing. But it provides you evidence that what you're doing is correct. So now when you know how to repeat, you're okay. So see right here, we got a little bit of some copper-like thing there. I'm not worried about that. Remember, 70% is the 70% or more coverage by surface area is considered a good joint. We're at least 95, 96%, if not more. So I have no problem saying that what I did is okay. Now, like I said, the solder joint is all the way pretty much down to here. All right, see the cross section, and this is a lot of capillary space. So the few thousandths of an inch that this is actually full of solder is going to make it waterproof for a very long time. All right. So with that being said, we want to make sure that when we have the ball valve in the position, our tip here, okay, is going to be applying heat, as low as we can without burning the seats, because if we flip this over, the Teflon seat sits just like this. All right. So imagine now this is the inside of the chamber, and we're putting heat, right along here. If you're putting it down this direction, notice my torch angle. See how torch angle is pointed toward that? You're going to put too much heat where you don't need it, and you're going to deform this. And I don't care how good this joint is, if you burn this, your ball valve ain't going to do nothing. All right. So what you want to make sure is you apply the heat on an angle up, so you're away from the Teflon, but you're still getting heat down. But people think, well, if I'm doing that, you probably can't get it. Well, that's the second tip. And because you've got this copper tube in there, use the copper tube. If I put the heat on the copper tube here, that heat where I'm applying it right now is going to go all the way down to here. So that's why you do combination of the socket and the tube. You do both. Socket here, tube here. And if you do both, the heat is going to go all the way down. So let's check this one here to see what we did on this one as well. So we just grab it here, and we look, we break. Aha, okay, look at this side. See, all right. So again, depends on how we heat. See, so again, we do have some bare spots. Again, it is still a very good joint, so I'm going to say overall we're probably at least 80% covered across both. All right, but this is considered a waterproof joint. Not a perfect joint, but it does mean I've got solder all the way down to where the water's starting. All right, in both cases. Right, I do have solder. Just gonna get these here in focus here. Okay, all the way down here, I do have solder, so that's very good. On this piece here, I don't have enough solder, so that would mean there's not enough heat, right? Or possibly flux came out, but generally the heat is the issue with this. But again, all solder. There's not any bare copper spots anywhere. The lines you see here are just pieces of, when the pipe went down in here, it just kind of put some flux in a radial pattern, but that is still 100% covered here. But overall, it's very good, but it's not perfect. This can be done better. If we look at the piece of copper that this came out of, again, see we have total copper coverage. See, here's the copper, right? Here's our bare spot. Now, because I have this much between the water here and the final non-solder point here, that again, it's a very good joint. We are very considered waterproof at this point. So because you have testing and you become comfortable, you will be getting better at how to produce joints faster and more reliably so they won't leak. So once again, any questions or comments, please post them. I hope that they were, hope the video was useful to you. I'll be putting up more in the future, but that is basically how to solder a ball valve in the most ideal position. All right, ideal is vertically in the vise with the solder being pushed down. I'll do future videos about how to do inline, horizontal, even upside down. But today was mostly just how to get the most ideal solder joint, how to clean it, how to fit it. And hopefully you found it useful. So thanks a lot, and again, post questions or comments below. Love to hear what you guys got to say, and I'll be back soon. Thanks.